Hello, my name is Paul Thompson, and I am answering questions for math, chemistry, and physics. And I've got a question to my right here from Who Answers, and it states that we have a rotating disk that is at rest at t equals 0. So write that now, t equals 0, with a constant angular acceleration. So our alpha, we don't know, but it's some constant, so I'll just call it k. Alright? And at one time it's rotating at 4 revolutions per second, so that's our omega naught equals 4 revolutions per second. And then 60 revolutions later, so theta equals 60 revolutions. And after 60 revolutions we got our angular speed, which I'll call omega, which is the angular velocity after 60 revolutions, equals 16 revolutions per second. Okay? Just as reference, I'll also note that my theta naught equals 0. You know, this is just my reference. When it's at rest, I'll just call it as. So now we can use our kinematic equation, which is omega final squared equals omega naught squared plus 2 alpha, and that's delta theta. So this right here is our actual change in theta, so I'll note that it's our delta. And we just plug in numbers now and solve for our alpha that we so desperately need. Alright, so that's going to be 16 squared equals 4 squared plus 2 times 60 times alpha. Alright, so solve for alpha here. Oh, sorry about that. Solve for alpha here. You just get 2 revolutions per second squared. Alright? Now we're going to need this for later use, which is starting at time equals 0, what is the time required to complete 64 revolutions. So, we also then are going to be using another kinematic equation, which is our theta final equals theta naught plus omega naught times delta t plus our alpha times delta t squared divided by 2. Alright? So our omega naught is equal to 0. So it's just not needed. Then our omega naught, well, our disk starts at rest, so this is also 0. So that factor cancels out. So we're left with that our theta final is 64 revolutions equals alpha times delta t squared divided by 2. Alright, so now, a little here. All we need is to solve for delta t. We already have our alpha, and our alpha is equal to, let me erase this. So these cancels, and our delta t squared equals 64. Just solve for delta t, and you get that it equals 8 seconds. And there